Ladies and gentlemen, I welcome you to our YouTube channel. My name is Professor Kevin. So please, if you haven't subscribed, just subscribe now and don't forget to like our videos and share with your friends or your fellow learners. So on this video, we'll be focusing on the derivatives of ordinary functions or the derivatives of polynomial functions. Okay, so before that, let's start with the rules, because it's very much important to know the rules of differentiation. So we have rule number one as constant rule. We have a constant rule. Okay. So the constant rule states that if you have a function of f which is equal to c, where c is a constant, c is a constant, so it means that the derivative of f or the derivative of c, it is going to be 0. So you need to know that the derivative of a constant, it's always 0. Okay, so for example, the derivative of 3, so obvious even 3 is going to be 0 because it's a constant. Okay, how about the derivative of a? So here you must understand that you are differentiating in respect of x. So a here, it is just a constant because you are differentiating in respect of x. Okay, so a, it is just a constant, so it means that the derivative of a, we are going to get 0 also because it is treated as a constant because we were differentiating in respect of x. So that is all about the constant rule. So now let's go to a power rule. So we also have power rule. So on power rule, so let's say we have a function of f which is equal to x to the exponent of n, where n is a constant. So this rule or this power rule, it only applies when the exponent is a constant. So if the exponent is not a constant, we are not going to apply the power rule. Okay, so you must make sure that your exponent is constant before you apply power rule. If it's not a constant, it means we have to apply some other rules. Okay, then the derivative of f or the derivative of x to the exponent n is that we are going to drop this exponent here, and then after dropping the exponent we subtract 1 from our exponent, so it will be n minus 1. This is how we apply the power rule. Okay, so let's say we are differentiating x cubed. So in this case, it means our n it is 3. So we're going to drop 3 and then we're going to subtract 1 from our exponent. And then it will be, sorry, not 2, this 3 minus 1, so it will be 3x squared as our final answer because we subtract 1 from the exponent. Okay, so even when we have the derivative of x, so here the exponent, it is 1. We just don't write that 1. Okay, so let's find out what will be the derivative of x. So it means we're going to drop that exponent of 1, and then we'll be having x to the exponent of 1 minus 1. So you see, we are going to have 1 multiplied by x to the exponent of 0. Okay, because 1 minus 1 is 0. So anything to the exponent of 0, it is the same as 1. So it means here we are multiplying 1 multiplied by 1, which is still the same as 1. So it means the derivative of x, it is 1. Okay, and then again, let's go ahead and differentiate 1 over x squared. So before we can differentiate, you must make sure that your term or your variable, it is in the exponential form. Okay, so when it's like this, we can't differentiate. We need to write this in an exponential form according to power rule. So it will be x to the exponent of -2. Okay, because we only apply power rule when it is in this form. So when it's not like this, we are not going to apply power rule. And then we must make sure that the exponent is a constant. So now we can be able to apply our power rule. So it means we'll drop our exponent, which is negative 2x, to the exponent of, we're going to subtract 1 from our exponent. So it will be giving minus 2x to the exponent of 3, which will be the same as minus 2 over x cubed if we write it in a positive exponent. Okay, so let's go ahead and do this. So we can go ahead and differentiate a square root of x. Okay, square root of x. So before we can differentiate this, we must make sure that it is in the exponential form. If it's not in the exponential form, we must express it in the exponential form, okay, using the laws of exponents. So before we can differentiate, let's write it as a square root of x. It will be the same as x to the exponent 1 over 2. Then now we can be able to apply the power rule, because we can see that our n, it is 1 over 2, or our exponent. So we're going to drop 1 over 2, which is our n. Then after that, we are subtracting 1 from our exponent. So it's 1 over 2 minus 1. So we're giving my 1 over 2x, the exponent, minus 1 over 2. Okay, so you can still write it as 1 over 2x to the exponent 1 over 2, which is the same as 1 over 2 square root of x, because exponent half, it is the same as square root of x. So that is the derivative of square root of x. So you need to understand these rules of exponent in order for you to be able to understand power rule. Then let's do the last example. Let's say we have 5x cubed plus 2 the fifth root of x cubed plus, or let's say minus 5x, 6x plus 7. So now we need to differentiate this, okay? But let's check whether our terms, are they in an exponential form. If we can check, we have this term, it's not written in an exponential form, so it means it is our duty to write it in an exponential form, okay? So it means the derivative of will be having 5x cubed plus 2, okay, fifth root of x cubed, which is going to be x to the exponent of 3 over 5 minus 6x plus 7. So now we can be able to differentiate this. Okay, so let's start. Here we are going to differentiate each and every term. Okay, we differentiate term by term. So we have 5x cubed as our first term. So there we are going to drop our exponent, which is 3. So 3, it will multiply with 5 and become 15. Then we subtract 1 from our exponents. We'll be left with 2. So we'll be having 15x squared plus, okay, we have our second term as 2x to the exponent 3 over 5. So we're going to take, or we're going to drop this 3 over 5 and it multiplies 2. So it will be 6 over 5 x to the exponent of, then we're going to subtract 1 from 3 over 5. So 3 over 5 minus 1, we are going to get minus 2 over 5. Then again, this differentiate minus 6x. There we are going to have minus 6, because we know that the derivative of x is 1. Okay, so we're going to drop that exponent of 1, it will multiply with 6, still the same as 6. Then we subtract 1 from the exponent, give us exponent 0, which is 1. So again, we have to differentiate 7. If we differentiate 7, 7 is a constant, so it means the derivative of a constant, it is 0. So you can just write plus 0, or you don't write it, it's fine. So this is our final answer. You can go ahead and write these things in a positive exponent. Okay, yeah, I don't like leaving my answer in a negative exponent, so you can go ahead and write it in the positive exponent, as you see here how we did it. So now let's go to a product rule. So we are going to talk about a product rule. So we apply the product rule when two or more functions are multiplying each other. Okay, for example, if we have r of x is equals to f of x multiplied by g of x. As you can see here, we are multiplying the functions. So it means the derivative of this one. This is how we apply the product rule. So the first thing is to keep the first function the way it is, f of x, then multiply by. So now you differentiate the second function. So we'll be having g prime x plus, okay, so now we are going to keep the second function, multiply by, so we're going to differentiate the first function. This is how power rule works. So let's say we have to differentiate x squared minus 1 into x cubed minus 3. Okay, as I said, it applies when we are multiplying two or more functions. So look, we are going to keep the first function the way it is. It is x squared minus 1. We multiply it with the derivative of the second function, which is x cubed minus 3 plus. So now we keep the second function the way it is, and then we multiply with the derivative of the first function. The first function is x squared minus 1. So let's simplify. We are having x squared minus 1. Okay, the derivative of x cubed minus 3, we are going to get 3x squared. This is a power rule. Plus, then we have x cubed minus 3. The derivative of x squared minus 1, we are going to have 2x. So now we need to simplify these things. Then we are going to have 3x to the exponent 4 minus 3x squared plus 2x to the exponent of 4 minus 6x. So let's add or subtract our like terms. So we have 3x to the exponent of 4 plus 2x to the exponent of 4. This will give us 5x to the exponent of 4, and then minus 3x squared minus 6x. So this is our final answer. So this is how to apply the product rule. So let's do the last example on our product rule. So let's say we have the derivative of x multiplied by 3x minus 2 multiplied by x to the power of 4 minus 1. Okay, so yes, if you can see, we have 3 terms. So if you want to make things easier, you can make sure that you multiply the first 2 terms, and then at the end you'll be multiplying 2 functions. You'll be multiplying 2 functions instead of 3, because when it is 3, it will be long and a little bit complicated. So let's do it like this. We're going to say d over the x. So you can multiply these 2, or you can multiply these 2. At the end, you must make sure that you have 2 functions multiplying each other. So let me multiply x and 3x minus 2. So it will give us 3x squared minus 2x multiplied by x to the exponent of 4 minus 1. So now we can be able to apply product rule very well. Okay, so we are going to keep the first function. It is 3x squared minus 2x, and then we multiply with the derivative of the second function. It will give us 4x cubed. Okay, plus we keep the second function. It is 4x to the exponent 4 minus 1. Then we multiply with the derivative of the first function. We are going to get 6x minus 2 if we differentiate the first function. Okay, we have applied the product rule. So let's see what we're going to have here. The method of simplifying now. So we'll be having 12x to the exponent of 5 minus 8x to the exponent of 4 plus 6x to the exponent of 5 minus 2x to the exponent of 4 minus 6x. Again, we'll be having plus 2. Okay, so it's the method of adding or subtracting like terms. 12x to the exponent of 5 plus 6x to the exponent of 5 it will give us 18x to the power of 5 minus 8 to the power of 4 minus 2 to the power of 4. It will give us minus 10x to the power of 4. Again, I don't see any like terms anymore, so it will be having minus 6x plus 2. So this is how we differentiate using product rule. So now we will be looking at the quotient rule. We are focusing on the quotient rule. So quotient rule, we apply it when we are dividing two or more functions. Okay, so if we have r of x is equals to f of x divided by g of x, so then the derivative of this is going to be, so the first thing that we do in a quotient rule is to square our denominator. Square it, and then after squaring your denominator, come and write it here. It is g of x. Come and write it there, and then you multiply it with the derivative of your numerator, f prime x, minus, then now you keep your numerator the way it is, multiply with the derivative of your denominator. So this is a quotient rule. So let's say we have to differentiate x to the power of 4 minus 4 all over 2x cubed minus 1. So we need to apply the quotient rule here. As you can see, we have functions dividing each other. So as I said, that the first thing is to square our denominator. So we are going to do the very same thing. 2x cubed, we have 2x cubed minus 1, so we are going to square it. 2x cubed minus 1 squared, and then we come and write it here. 2x cubed minus 1. We multiply it with the derivative of your numerator, which is x to the power of 4 minus 4, minus, we write our numerator x to the power of 4 minus 4, and then we multiply our numerator with the derivative of our denominator, which was 2x cubed minus 1. So let's see what we are going to have here. So we are having 2x cubed minus 1. If we differentiate x to the power of 4 minus 4, we will end up having 4x cubed minus, then let's keep x to the power of 4 minus 4, and then we differentiate 2x cubed minus 1, and then we'll end up having 6x all over 2x minus 1 squared. Okay, so now is the matter of adding and subtracting our like terms, or let's simplify first. So we're having 8x to the exponent of 6 minus 4x to the exponent of 3. Again, we'll be having minus 6 to the exponent of 5 plus 24x. All these things divided by 2x cubed, 2x cubed minus 1 all squared. So yeah, I don't think we have like terms there. So this is how we apply the product rule. So the quotient rule is very simple. Okay, so oh sorry, I made a mistake when I differentiated this one. We are going to get 6x squared, not 6x, né? 6x squared. Sorry for that. Let me fix it. We are going to have 6x squared. Okay, because when you subtract 1 from 3, we're going to get 2. So it means now we'll be having x to the power of 4 minus 6x squared. We're going to get 6x to the power of 6, and then plus 4x squared. So we have like terms now. These two are like terms. Then we'll be having 2x to the exponent of 6 minus 4x cubed plus 4x squared and 24x squared. Sorry, it is 24x squared because 4 multiplied by 6 is going to give us 24 all over 2x cubed minus 1 all squared. So this is our final answer. So let's do the last example on our quotient rule. So let's find the derivative of x squared minus 1 over 2x plus 1 and plus 3. It's fine. So now if you can see, this is a function where we are dividing two functions. Okay, so it means we are applying the quotient rule, and then in the quotient rule we start by squaring our denominator, which is 2x plus 3 squared. After squaring our denominator, we come and write it here, 2x plus 3. As you can see here, we're squaring g of x, and then we came and write it there. Multiply by the derivative of your numerator. Our numerator, it is x squared minus 1, okay? X squared minus 1. Then minus our numerator, which is x squared minus 1. We multiply it with the derivative of the denominator, which was 2x plus 3. So now let's see, we are going to have 2x plus 3. It will be multiplying the derivative of x squared minus 1. We are going to get 2x minus x squared minus 1. The derivative of 2x plus 3, we are going to get 2 all over 2x plus 3 all squared. Okay, let's come and finish it here. We'll be having 4x squared plus 6x minus 2x squared minus plus 2, because negative and negative becomes positive, divided by 2x plus 3 all squared. Then let's see, we have 4x squared minus 2x squared, which will give us 2x squared plus 6x plus 2 all over 2x plus 3 all squared. So this is our final answer. So we are done with the quotient rule. So now we are going to the last rule, which is called chain rule. So here what happens in chain rule is that you differentiate what's inside. You start by differentiating what is inside, and then you keep what's inside, and then after that you multiply with the derivative of what is inside. So here it's what I mean. So if we have f, or let me call it function of r of x, you have f of g of x. So the derivative here, then when we differentiate r, okay, so let's apply the chain rule. I said you differentiate what we have outside first. So we have f prime, then you keep what you have inside the way it is, and then you multiply with the derivative of what is inside. This is how we apply our chain rule. Okay, for example, if we have to find the derivative of x squared minus 4x all to the power of 3, okay, so let's apply the chain rule here. So what you need to do first here is that you need to differentiate what you have outside, right? Then after that you go inside. So we are going to apply the power rule. Firstly, we're going to drop this exponent of 3. So given 3, then you keep your inside the way it is, x squared minus 4x. Then we subtract 1 from our exponent, and then we have exponent of 2. And then now we multiply with the derivative of what we have inside, which is x squared minus 4x. So this will give us 3 into x squared minus 4x multiplied by Okay, the derivative of this is going to give us 2x minus 4. And then if you want, you can take out the factor of 2 outside, or you can go ahead and multiply these things. And then let's see what we'll be having if we multiply this. We will have 2x cubed minus 4x squared minus 8x squared plus 16x. Okay, so now is the matter of adding and subtracting our like terms. So we will be having 6x cubed. I multiply with the 3 that we have outside. Then here we'll be having minus 12x squared, and then we'll multiply it with 3, and then minus 36x squared plus, again we are going to have 3 multiplied by 16x, which is going to give us 48x. So that is the derivative of what we have there. So that's all. Okay, oh sorry guys, sorry for this. We have a squared here. I mistakenly forget this square. Okay, so we're not going to multiply it in this way. Sorry for that. I hope you end up getting the point. So I mistakenly forget that a squared. So in other words, we can leave it here. There's no need for us to go ahead and simplify, because it will take long if you want to simplify, but you can go ahead if you want. It's not a problem. But at the end, you must make sure that you understand how to apply the chain rule. That's what is important. So let's do the last example, or the next example. So now we need to find the derivative of square root of 2x cubed plus 3. The derivative of square root of 2x cubed plus 3. Okay, so what we need to do first is to write this square root in an exponential form before we differentiate. So we will be having 2x cubed plus 3 all to the exponent of 1 over 2. So now we can be able to differentiate. So we're going to drop this exponent of 1 over 2 here, and then we write what we have inside the way it is, 2x cubed plus 3. We subtract 1 from our exponent, and then we are going to get minus 1 over 2. Then we multiply with the derivative of what we have inside, which is 2x cubed plus 3. So this is going to give us 1 over 2. Or let's write this in a positive exponent. Or yeah, it will be 1 over 2 into 2x cubed plus 3 raised to the exponent 1 over 2 multiplied by the derivative of 2x cubed plus 3 is going to give us 6x squared. So our answer, we can write it as 6x squared all over, okay, before that, this 6 will divide with this 2 here. Then we'll be having 3 instead of 6x squared, because we have, this is like 6x squared over 1. So 6 and 2 will divide each other, and then we'll be left with 3x squared over, let me write this as square root of 2x cubed plus 3. So that is the derivative of square root of 2x cubed plus 3. So this is how we apply the chain rule. We start by differentiating what we have outside, and then after that you differentiate what we have inside. Simple as that. Let's do the last. So now we need to find the derivative of 4x plus 3 over 5x minus 2 all to the power of 3. So this one, we are still going to use the chain rule. Okay, so the first thing is to drop our exponent. We have exponent 3, then we'll be having 4x plus 3 over 5x minus 2. Then we are subtracting 1 from our exponent, then it will give us 2. Then we multiply with the derivative of what we have inside, which is 4x plus 3 over 5x minus 2. So for this one, we are going to apply the quotient rule. As you can see that these functions are dividing each other. So it means on the other side, we are going to apply the quotient rule. So that's why it's very much important to know all these rules. You have to know all of them. You don't choose. You have to know all of them in order for you to be able to apply this thing very well. So here, as I said, we're going to apply the quotient rule. We are going to square our denominator 5x minus 2 square. Then we come and write it here. It will be 5x minus 2. After squaring it, we multiply with the derivative of our numerator. It will be 4 because the derivative of 4x plus 3 is going to give us 4. Minus, we write our numerator 4x plus 3, and then we differentiate our denominator 5x minus 2. The derivative of 5x minus 2 is going to give us 5. That is the quotient rule. So now what we need to do is just to simplify all this whole thing, and then we'll find our final answer. That's all. So let me break it down for you. We'll be having a 3 into 4x plus 3 over 5x minus 2 squared. Then on our numerator, we're going to have 20x minus 8, then minus, going to have a 20x again minus 15 all over 5x minus 2 squared. Okay, so that is what we'll be having on our numerator. So now is the matter of adding and subtracting our like terms. So if you can check, we have 20x minus 20x is going to give us 0. Then we'll be having minus 8 minus 15, that is going to give us minus 23. So we can take that minus 23 and multiply it with these 3 that we're having outside. Okay, so to give us minus 69. So we can write minus 69 all over 4x plus 3 over 5x minus 2 squared into, it means we will be having 1 over 5x minus 2 squared, just like that. So that will be our final answer. I hope you have enjoyed this video. Please guys, don't forget to like and subscribe to our channel, and also share this video with your friends or fellow learners for more content. Okay, so if you have some challenges on maths, you can simply WhatsApp me on this number 066 276 4810. We also have online sessions. If you need to book for online sessions, you can WhatsApp me or call me on that now. Thank you.